All right, I'm going to get started on homework number 23, and it is called logarithmic functions. And in this lesson, we are going to introduce logarithms. And let me rewrite that. Logarithms. And logarithms are really just the opposite of exponents. All right, so we've talked about addition and subtraction. Those are opposites. Multiplication and division, those are opposites. But being able to have the opposite of an exponent. So if you have a number, let's say 3 to the power of 4, right? How can we, and say that's equal to x, how can we write that in logarithmic form, right? Or even moving back, let's say, okay, so we have 2 to the third power. 2 times 2 is 4, times 2 is 8. You know that's equal to 8. So that would be called index form, right? That's what we have been using. Okay, you've seen that very often. But you can write this same equation in a different form, okay? And it's called logarithmic form. Logarithmic form. Okay, and you can write that same equation like this. You can say log 2 of 8 equals 3. And really what that means is if you're trying to find 2 to the what power equals 8, so it's almost like 2 to the what power, we don't know what that number is, equals 8. If you're trying to find that number, you can use a logarithm. Okay, so we're going to learn more about logarithms throughout this lesson, but what you need to know right now is you look at this number down here, 2 to the what power, so 2 to the what power equals 8. And we know that 2 to the third power equals 8, so the log 2 of 8 is equal to 3. Okay, so you can switch back and forth between logarithmic form and index form. And we'll be doing that frequently here. But we'll be learning more about logarithms throughout this lesson. And one of the best ways is to learn by doing. All right, so, when we move back and forth, take notice here, right? If I were to just say, I don't know, let's say I were to write that number out in front. So if I were to write like 8 equals 2 to the third power, right? We could just identify 8 in this case as n. And we could just say this number is a raised to the power of x. And then if you wanted to convert that into logarithmic form, you could write the log of a, log a of n is equal to x. And really, if you're looking, the a that started here, well, let's start with the n that started here ends up going right there. The a that started right here ends up going right there. And the x ends up being the answer. Okay, so using the same exact variables, the same exact numbers, just moving them around. So like if you had, once again, that last example that I gave you, 8 equals 2 to the third, and I said write this in logarithmic form, what you would do is you would first just write log, right? That's the first step. So I'll make steps, right? First step, write log. And then once you've written log, right, find out what number is actually being raised to the power of something, right? So you would look at 2 in this case, and 2 is going to be your subscript down there, all right? And then we're going to take, so I'd say a equals your subscript, okay? And then I'd say for b, whatever your n is, in this case, right now, n is 8, so n is going to be the number that you're trying to find the log of, right? So you would just put log 2 of 8 here. And then the answer, so the answer is x. So we're going to go ahead and take this 3 and move it there. So remember, n equals a to the x power, right? A is going to be 2. So I'll say, in this case, a is 2. And in this case, n is 8. And x is going to be 3. So you really just substitute those values. A is your subscript down here, which is 2. 8 is your n, and x is 3. So it's just another way of writing it. And by writing out log, that might seem confusing. Like I said, the best way we're going to get this is by practicing. So we're going to move on. Right, I really like that color that we had before, so I'm going to do this. I'm just learning new things here. All right. So I'm going to move on. We're going to say number 1. All right, number 1 has it written out. 49 is equal to 7 squared. And we know that 7 squared is going to equal 49. So we want to write this. The directions say write each equation in logarithmic form. Okay, so we wanted to send this over to logarithmic form. So the first step was just to write log, identify what my subscript is going to be. Okay, so it's going to be 7. All right, and then 49 equals 2. And the way I can check and make sure this is right, you can read this as 7 to the what power equals 49. So 7 to what power equals 49? Well, 7 squared equals 49. So I know that I've written this out properly. Log 7, 49 equals 2. And that would be my answer. All right. Number 2. Number 2, I have 10 to the power of 3 equals 1,000. I know this to be true. I could put it in my calculator, right? And I know it to be true. Let's go ahead and put it in logarithmic form. So the first step is to just write log 10, okay, is being raised to what power to give me 1,000? Log 3, okay, 10 to the third power equals 1,000. So log 10 of 1,000 equals 3. That's all we're starting off here doing. All right, number 3. I get 625 equals 5 to the 4th power. All right, we want to put that in logarithmic form still. So the first step is just write log, okay, and then 625. So 5 to the what power equals 625? 5 to the 4th power equals 625. All right, and that's my answer. All right, we'll get the hang of this. Number 4, like I said, we got to practice. The more you do it, the better you'll get at it. Say 8 squared is equal to 64. I know that's true. But let's go ahead and write it in logarithmic form. So I can say log 8 of 64 equals what? Equals 2. 8 squared equals 64. 8 to the power of what equals 64? 8 to the second power. And there you go. And that's number 4. All right, number 5. It says to evaluate each logarithm. So the first logarithm they give me, say log 2 of 16. And evaluate means find out what the answer is. So 2 to the what power equals 16. So 2 to the what power equals 16. Well, 2 times 2 is 4, times 2 is 8, times 2 is 16. So really, 2 to the 4th power equals 16. Right? I always like to think of it as you have 2 to the what power, and I imagine like a power up there. 2 to the what power equals 16. And then the answer goes on my right. All right? That'll be my answer. Well, I guess I can just say 4. Okay. Number 6, I have log 4 of 2. Now, don't get tricked here and put 2, because that's not true. Okay. 4 to the what power equals 2. So 4 to the what power equals 2. And it's not to the second power. It would be 4 to the 1/2 equals 2. All right. So my answer here is going to be 1/2. All right. That's number 6. Moving on. Number 7. I have log 8 of 8 equals what? 8 to the what power is 8? 8 to the first power is 8. 8 to the first power equals 8, right? So there we go. Number 7 is 1. Let's move on here. Number 8. I have log 2 of 8. 2 to the what power equals 8? 2 times 2 is 4, times 2 is 8, so I know that's going to equal 3 because 2 to the third power is 8. So the answer here is 3. All right. Moving on to number 4. All right. I'm sorry, number 9. I wrote 4. I said 4, but I wrote 9. Number 9. The directions say to write each expression as a single logarithm. I keep wanting to say algorithm from computer science here. So I have log 7 plus log 2. And it tells me to write it as a single logarithm. Now, when you're adding together two logarithms, you can just combine the logs and multiply these two numbers right here. Okay, so that's all. You can just combine them together. If you have log 7 plus log 2, all you're doing is just saying log, and you multiply these two numbers together. So 7 times 2 is 14. And that would be my answer. This is how you would combine logs together. And, there's no rhyme or reason behind it. You memorize that and know that when you have two logs, you can always, and you add them together, that means just multiply them together. And if you have two logs that are subtracted, right, you would divide. Addition, you get multiplication here, and subtraction, you're going to get division. So in this next example, right, if you have log 2 of 9 minus log 2 of 3, okay, what you want to do here is you want to write log 2 of 9 over log 2 of 3. 9 log 2 9 divided by log 2 3. Okay, you can do this if your logs match up. Notice you have log 2. Okay, so 9 divided by 3 is 3. So my answer here is just going to be log 2 of 3. Okay, you keep everything else the same, and you just take 9 divided by 3. Now, I realize this, and I want to go back and talk about this. If you look at number 9, there's no subscript down here, right? You don't have a number. Whenever there isn't a number down there, the same way with a square root symbol, whenever there isn't an actual number in the radical, right? Without that index, if there's nothing there, like in this example right here, then it's really just a 2. And with logarithms, right, and I'm looking down at number 9 now, with logarithms, if there's nothing there, then really that's just log 10. Right, and you could write it like that. But it's just a shortcut. Log 10 is used so often, the same way square root is used so often, that they don't even include it in there. So you don't even need to write it if it's log 10. You can if you want. All right, and that is number 10. I'm going to do that same thing. Drag that in, and then I'm going to change the color to white. All right, that was number 10. Now we'll move on to number 11. Number 11 is 5 log 3 plus log 4. Okay, so now we have a number out in front of log. What do we do with that? And remember, if you really want to write it as a 10 down there, you can. You don't have to. I'm not going to. I'm just going to just always remind you of that. Okay, so that 5 out in front, really that just means to raise whatever I have, log 3, raise it to the 5th power. Okay, plus log 4. Okay, so if I move through here, log 3 to the 5th power. If I take 3 to the 5th power, I get 243. So log 243 plus log 4. Okay, I'm trying to reduce this down and to write each expression as a single logarithm, so only one. All right, so what I want to do here is, since I have addition, I can multiply, right? You multiply these two numbers together, 243 times 4. And if I take 243 and multiply it by 4, I get 972. So I would get log of 972. And that's all it's asking me to do. I could type it in my calculator and get an answer if I really wanted to, right? If I type in, and if I say log of 972, I would get 2.9876 repeating. Right, so I could find that out, but it just says to write it as a logarithm and keep it there. So that's what I'm going to do. All right, number 12. Number 12, it says log 8 minus 2 log 6 plus log 3. All right, so we want to move from left to right here. And if I take log 8 minus 2 log 6, I guess I can write this as log 2 to the 6, log 6 to the 2nd power, because I take that 2 and I move it up here, right? So log 6 to the 2nd power plus log 3. Okay, subtraction right here, this subtraction symbol means I have to divide it. So log 8 divided by log 6 to the 2nd power is 36. Okay, I'm going to take that, and by adding log 3, really that's the same as multiplying. So I'll go ahead and multiply it by log 3. Okay, so if I'm multiplying straight across here, right, because log 3 is the same as log 3 over 1, right? Log 8 times log 3, that means 8 times 3. 8 times 3 is going to be log 24, all right, and then over log 36. I can reduce this down because it's a fraction. If I have like 24 over 36 as a fraction, I can divide the top and the bottom by 12, right? That makes it into its simplest form. 24 divided by 12 is 2. 36 divided by 12 is 3. So that gives me 2/3. So really that condenses it down to log of 2/3. Because I could have written it as log of 2 over log of 3, but I'm sharing the log on the top and the bottom, so I can just write it as the log of 2/3. And that's my answer, log of 2/3. And that was 12. So we've written each expression as a single logarithm. Now we're going to take these single logarithms and we're going to expand them, all right? So let me go ahead and go back to this color here, go ahead and make this white. Okay, so the directions say expand each logarithm. And I'm going to do number 13. Number 13 is log x to the third power times y to the fifth. Okay, and the way I would write this is, I know x is raised to the third power. So remember when we had a number out in front, let me say like 2 log to the third, I could rewrite that as like log 3 to the second power, and then eventually I could say log 9. Well, in this case right here, I'm going to go ahead and expand this out. So I'm going to go ahead and take all that out there. I'm going to expand this, and I'm going to say 3 log x. I took this 3 and just moved it to the front there. Plus 5 log y. I took this 5 and moved it out to the front. So the same way how we condensed them before, I could look at this and I could easily condense it together by multiplying all this. Okay, so you go back and forth in the directions right now. It tells me expand each logarithm, so that's what we're doing. That was number 13, and we're going to move on to 14. Okay, 14 is the log 7 of 49 x, y, z. We're going to do the same thing. We're going to expand it. All right, and I'm going to say the log 7 of 49 plus the log 7 of x plus the log 7 of y plus the log 7 of z. And some of you might just stop here and just quit, but really, the log 7 of 49, 7 to the what power is 49? 7 to the second power is 49, so I know I can take this right here and I can evaluate it to 2. So I can say 2 plus log 7x plus log 7y plus the log of 7z. And that would be my answer. All right, that's what I got. Number 15, it's an easy one. Number 15 just says log a to the second power. Okay, it says to expand it. I can do that. I can just write that as 2 log a. Take that 2 that was there, put that out in front, and I get 2 log a. All right, 16, 17, and 18 use this thing called the change of base formula. And the change of base formula is a way to evaluate logarithms here that we aren't able to quickly find the answer to. So 2 to the what power is 9? I don't know, right? 2 to the what power is 9, right? That's not something, it's a decimal. It's not a pretty number. So what I can do is, I can say, by using the change of base formula, I can just say log 9 divided by log 2. And the way that I get that is, you can just almost just draw a line here. That's how I could do it. I draw a line and then just write log underneath of it. It allows you to do that because really you'll find out that log 2, 9 is the same exact thing as just writing log 9 over log 2. So like if you have like log 2, 8, you could rewrite that as log 8 over log 2. Okay, and if I were to type that in my calculator, I would still get equals 3. So on my calculator right here for number 16, going back here to this part of the problem right here, log 9, I'd type my calculator, log 9, and then say divided by log 2, and then click enter, and I get 3 point, and it tells me to just evaluate the expression to the 100th. Okay, so this is tens place right here. This is the 100th place. So 2 point, we'll do 1. It says 169, but I'll round up to 17. If you're like 1 off, that's fine. I'm not asking for it to be super perfect. Just identify the answer there. Okay, so I get 3.17. Number 17, if I have log 12 of 20, okay, I'll take log 20 and divide it by the log of 12. So I'll type in my calculator. The log button is near the bottom left of your calculator. So I'll type in log 20 divided by log 12, and I get 1.205. So if I'm just rounding to this place right here, I'll round up to 1.21. All right, and that's what I get for 17. I'll squeeze 18 in here down at the bottom. And this is, it says log 5 of 10. 5 to the what power is 10? I don't know off the top of my head. So I'm going to use the change of base formula and find out what the log of 10 divided by the log of 5. And I get 1.430, so 1.43 is my answer. And that was number 18. Okay, moving on to 19 through 22. It says solve each equation. All right, so in this one I have 19, and it says 2x equals 8. So we can, I put this problem in here for a reason. You can easily just answer this off the top of your head and say, oh, well, 2 to the third power is 8. Well, I could rewrite this, right? I can say 2 to the x is equal to 2 to the third, right? Because 8 is 2 to the third. And that just makes it so easy. That makes it say, okay, well, x is equal to 3. And I could write it like that, x is equal to 3. And I'm done. And that's important because when I move into number 20 here, it starts looking a little bit more complicated. 4 to the 3x. So now we have a variable in the exponent, and we have to deal with that. All right, so remember my last example right here, number 19, I took 8, and I said, all right, how do I make the base, the 2, how do I make it into the same as what was over here? And I was able to do that. So if I'm looking at this, I can rewrite this as 4 to the 3x equals 4 to the what power equals 64. I can rewrite this as 4 to the third power. 4 times 4 is 16 times 4 is 64. And now, if I know this is true, the same way in this example right here, where I knew if I had the same base, that these two would be equal to one another up here in 19, I'm going to assume the same thing. I'm going to assume that in order to solve this, 3x is equal to 3. And if I divide by 3 on each side, I get x is equal to 1. And let's test that out. Let's check it. 4 to the third power times 1. Is that equal to 64? Well, that gives me 4 to the third power is equal to 64. Is 64 equal to 64? The answer is yes. So I know that my answer must be right. Number 20. All right, moving on, number 21. 21 is 3 to the power of negative 2x plus 2 equals 81. All right, so once again, I can rewrite this. 3 to the what power equals 81? 3 squared is 9, times 3 is 27. I can say 3 to the fourth power is 81. which then means that negative 2x plus 2 is equal to 4, right? Because 3's are the same there. If I know they're equal to each other, then those two must be equal to one another. So if I subtract 2 from each side, I get a negative 2x is equal to 2. Divide each side by negative 2, and I get x is equal to negative 1. Let's test it out. Let's see if that's right. I'm going to check my work. Get in the habit of checking your work. Right, it's just the original equation. I substituted in negative 1 for x. Multiplying through 3, and then negative 2 times negative 1 gives me a positive 2 plus 2 is equal to 81. 3 to the 4th power is 81 is 81 equal to 81. 3 times 3 is 9 times 3 is 27 times 3 is 81. Is that true? Yes. And that's number 21. All right, last one here. All right, the last one is number 22. And number 22 has 3 to the power of x plus 2 equals 27 to the power of 2x. All right, something just slightly different here, but it does make sense. You just have to pay attention to what I do. All right, so we have, I'm going to rewrite 3x plus 2. And how can I write 27 with a base of 3? Well, I can do that by saying 3 to the 3rd power, right? But I still have to multiply it by 2x that's up there. 3 to the 3rd power is 27. All right, so if I know these bases are the same, I can get rid of them and just say x plus 2 is equal to 3 times 2x. X plus 2 is equal to 3 times 2 is 6x. Subtract x from each side. I get 2 is equal to 5x. Divide it by 5 on each side. And I get x is equal to 2/5. All right? And that's my answer. So that one was a fraction. I know you guys don't like fractions and decimals when I give it to you, but I wanted to at least give you one here. All right, x would be 2/5 in this example. But that was homework number 23, logarithmic functions. Let me know if you have any questions.